friends, let us see video number 57 of chapter number 13. In this video, we will see about atomic size or atomic radius of a nucleus. After Geiger-Mercian experiment, Rutherford come to know there is an existence of nucleus, right? So what should be the size of the nucleus? Let us see. In that experiment, what was there? There was bombardment of alpha particles having kinetic energy how much? 5.5 MeV. This alpha particles was bombarded on which metal? Gold foil, right? Gold foil. Then there was a scattering of alpha particle. So here there was a scattering of alpha particles, right? This experiment we know very well, and after that Rutherford has concluded the scattering of alpha particles indicates that at the center all positive charges are concentrated, and that positive charges which is present at the center of an atom is known as nucleus. Clear? This thing already we have seen twice in previous videos. Now what is the different thing? Okay, so when alpha particles having kinetic energy 5.5 MeV is bombarded on a gold, there is scattering of alpha particles. The scattering of alpha particle is purely based on Coulombian repulsive force. Got it? And due to this Coulombian repulsive force, there is a repulsion of alpha particles. That repulsion is maximum from the center, and then it is considered that the closest distance of approach is about 4 multiplied by 10 raised to minus 14 meter. Got it? So this closest distance of approach means that alpha particle may go inside the atom of gold. How much close it reach to the nucleus, that is known as closest distance of approach of alpha particle where near the nucleus of gold. So it is considered that the nuclear radius may be 4 multiplied by 10 raised to minus 14 meter. But there are few things. First thing, if the energy of that alpha particle increases, then if we increase the energy of alpha particle, that means instead of 5.5 MeV, if the kinetic energy of alpha particle increases, then we have to consider this fact. If energy of alpha particle increases, alpha particle may go again nearer to the nucleus. Means the closest distance of approach was considered 4.0 multiplied by 10 raised to 14 meter if the kinetic energy is 5.5 MeV. If kinetic energy increases, this closest distance decreases. Means 4 multiplied by 10 raised to 14 meter is not fixed as a size of nucleus. Got it? So if energy increases, distance, now you have to consider that distance, which distance? Closest distance of approach. This distance decreases. Now Rutherford have made another experiment. Instead of that alpha particles, he took fast electrons as a projectile. I spoke new word. Which word? Projectile. Projectile, they are the particles which is used to bombard on metal. So, in this case, our projectile was alpha particles. Right? Now, Rutherford has made one more experiment in which that projectile he took which fast electrons. Means fast electrons. These fast electrons we have to take as a projectile. Got it? Projectile, they are the material which is used to bombard on the atom, on the element, on the nucleus, whatever. Okay? If instead of alpha particles, there is a fast electrons, then also this closest distance of approach again decreases. Means previously from the standard experiment it was concluded that the closest distance of approaches was 4 multiplied by 10 raised to minus 14 meter, but there are two cases. Case number 1, right? Case number 1. If the energy increases, energy of alpha particle increases, the closest distance of approach of that alpha particle decreases. Here, case number 2, right? This is case number 2. In the same experiment, instead of alpha particle, if the fast electrons are taken as a projectile, then again the closest distance of approach decreases. It means nuclear radius is not fixed. As per Rutherford experiment, it was 4 multiplied by 10 raised to minus 14 meter, but due to this, case number 1 and 2, it is concluded that nuclear radius is not fixed. Because of that, we have to take its average radius. Okay? Then the equation of average radius is given by, after number of experiment, it is concluded that R is equal to R0 a raised to 1 by 3. What is R? R is nothing but it is average size or radius. R0 is constant and it having value 1.2 multiplied by 10 raised to minus 15 multiplied by 10 raised to minus 50 meter. What is A? A is nothing but atomic number. Atomic number means density, mass density, per unit volume. Got it? So this is the equation to find the average radius of n nucleus. Got it? So from this equation we can see that what r is equal to, this term is constant, and here there is a raised to 1 by 3, or you can say that r is proportional to a raised to 1 by 3. Take 1 by 3 here, you will get a is directly proportional to r cube. Got it? Mass per density, that is mass density per unit volume, is always constant. Mass density of that protons as well as electrons, mass density of that nucleus per unit volume is constant. And because of that reason, we can see that as mass increases, the radius increases by q. Got it? So as atomic mass of that nucleus increases, radius increases by q. Okay? So this is about atomic size or atomic radius. Have a look. Then after we will see few sentences which is important for our short question. Have a look. Okay, there is one more thing which I have seen in that reference book also. Okay, in our assignment also that is there. Okay, it is surprise for you. Okay, I have seen one graph. It is like this. Distance against nucleons. What do you mean by nucleons? Nucleons means it is a combined name of protons plus neutrons. Got it? So protons and neutrons both are available inside the nucleus. Right? So this is the graph. It is like this. Okay? What actually it shows? This is the origin of that axis. This origin is nothing but center of nucleus. That is O. See, it is purely for your understanding only. You can see that at the center of nucleus, this graph starts from maximum value. Okay, so you can say that here density of nucleons are maximum. Got it? It indicates that at the center of nucleus, the number of protons and neutrons per unit volume is maximum. And as you move away, means like this, as distance increases, you can see that the graph decreases. The graph decreases means the number of nucleons. It indicates that the density of nucleons, that density decreases. Because of that reason, the nuclear radius is not fixed. You will find this region, right? In this region, you can say that mass density is very low. Got it? So it is also a reason which indicates that the radius of nucleus is not fixed. If it is fixed, then the graph must be like this. But there is some region where the amount of protons and neutrons are available, right? So this is another fact of that radius, and because of this reason we are taking average value of radius, that is r, and that equation we have seen previous. Okay, that is r is equal to r0 a raised to 1 by 3. This graph is available in our reference book as well as it was there in our textbook, right? Old textbook. But in our new textbook in CBSE, the radius is different. That is r is equal to r0 a raised to 1 by 3. This fact is explained in terms of first case number 1. What was that? If the kinetic energy of alpha particle changes, that means instead of 5.5 MeV, if the energy increases, the closest distance of approach decreases. Means that alpha particle may go deep inside the atom, may go nearer to the nucleus, and because of that, the closest distance of approach may be changed. Not only that, what was case number 2? Instead of alpha particle as a projectile, if fast electrons are taken, then also the closest distance of approach also changes. Got it? And because of these two reasons, instead of a radius of nucleus, we have to take r, average radius of the nucleus. R0 is constant, a raised to 1 by 3. Got it? From that, we have obtained one equation, one relation, which was there, A is directly proportional to R cube. What it indicates? As A increases, means mass density increases, mass per unit volume, mass of protons and neutrons, they are known as nucleons. As the nucleons increases, radius increases 3 times. Got it? So this is about atomic size, or you can say atomic radius of the nucleus. Right? Two things we have learned. One from our NCERT textbook and another by the help of graph. Both are very easy. Have a look. Enjoy. Thank you.